Okay, so the next thing that we're going to take a look at is how do we linearize or make a power function that is linear. Now, all a power function means that x is a base that's raised to an exponent. So your power function here, notice the difference. So linear is y equals mx plus b. Okay, so x does not have any exponent. Exponential function is y equals a times b to the x, where x is your exponent, and a power function here is y equals a. X is your base and it's raised to an exponent, okay? So our goal here is to make this function linear. Now, once again, I'm just gonna quickly show you how to do that. You don't necessarily have to know how to do that. I just want you to know where this is coming from. So let's say this is our power function. Now, in order to make this linear, basically what we have to do here is get rid of the exponent. So you cannot have an exponent on x to have a linear function. Okay, so what you're going to do is you are going to take the log of both sides. All right, so if I take the log of both sides, okay, I'm going to put this whole thing in parentheses. Notice, remember, let's use our properties here, that if you're multiplied, what you can do is separate that into two addition signs, okay? So now in my next step here, if I notice, I still have this b. Remember, you can pop that as a coefficient out front. Now, let's take a look at our new equation. So this is as simple as it goes. We have the log of y equals the log of a plus b times the log of x. Now, let's just think about what this means. So we have the log of y. This is basically the same thing as my y. Log of a, this is the same thing as my y-intercept, okay, because log of a is just a number. And then plus b log of x. Now, this is my slope, but notice what I've done here. This is my x. I have taken both the log of y and the log of x. So if you have an original equation that is x comma y, and you take the log, I apologize, I'm not quite sure why that keeps doing that. If you take, let's start this over again. Okay, if you take this and you're writing, you take the log of x and the log of y, then that is going to give you a linear transformation. Okay, now notice the difference here between the exponential one is that you had to take the log of x and the log of y. Now, how I remember this is, I think, powerful, a power function, I had to do more powerful things. I had to take the log of x and I had to take the log of y. Therefore, it started out as a power function and not an exponential function. All right, so let's take a look at this nonlinear data representing the average length and weight of different ages of Atlantic Ocean rockfish, okay? So this is our X in years and this is our Y in the weight. So let's enter the data into your calculator. So remember, this is list 1, this is list 2, and let's graph it, okay? So after we graph it, you should notice that it is a curved function. So what I want you to do is I want you to put the log of x in list 3 and the log of y in list 4. So basically you're going to have list 1 is your x's, list 2 is going to be your y's. To get list 3, you're going to highlight list 3 and you're going to take the log of list 1. That's going to make this the log of x. And then in list 4, you're going to take the log of list 2, which is going to make this the log of y. Now, in order to determine which is the best fitting linear model, so our goal here is we're not sure, okay, we originally started with x comma y. We're not sure if x log of y or if log of x log of y is going to make it more linear. Okay, so first you're going to graph your original function, which is x and y, and let's compare the r and the r squared values. Then you're going to graph L1 and L4, which is x log of y, x log of y, get the regression equation and find r and r squared. Then you're going to graph L3 and L4, which are log of x log of y, get the regression equation and r squared. Once you do that, you're going to determine which is the best linear model. Look at the graph, see which one is the best linear model, and then you're going to get the regression equation from log of x, log of y. So you're going to use list 3 and list 4 to get the regression equation. Get the regression equation for x log of y, which is list 1 and list 4. That's what you're going to get the r and r squared values here for. So what you're going to do is you're going to look at the r and r squared values and see which ones are closer to 1, and that will tell you which is a better model. Okay, so let's see what that looks like. So this is our original data. If you graph this, you kind of notice that this is curved. Okay, if we take a look at our transformed equation, this is x log of y. So this was using list 1 and list 4. And it's still a little bit curved. Now here we have log of x log of y. That's pretty linear, so that's pretty good. Then after you graph it, immediately find the regression equation. So notice we know that this is curved, so we know that that's not going to work, okay? Now, if we notice here, we could maybe say this is linear, but I can still kind of see the curve in it. Okay, now look at your R value and your R squared, 0.94 and 0.97. When I graph this, it's very linear. And when I look at the R squared and R value, they're both 1. That actually means it's a perfectly linear relationship when I take the log of X and I take the log of Y, okay? So this, knowing that the log of X and log of Y made it linear, allows me to know that this is a power transformation, which means my original graph was in the form Y equals A, X is your base, and then you had some sort of exponent at the top, okay? All right, so now let's just take a look at this for a second. How do we write our equation? So when you get your regression equation, remember we're gonna do list 3, comma list 4, because log of X and log of Y, this was list 3 and this is list 4, made our graph linear. So we have to use list 3 and list 4 to get my regression equation. You might look at this and say, oh, let me write my equation as y equals 2x plus my y-intercept, which is 0.477. But please be careful with that. Look at that and say, this is not correct. Why is this not correct? Well, the reason it's not correct is because I did not use x comma y to write this equation. I used log of x, log of y. Therefore, in front of each of these, I have to put that word log. Okay, so log of y hat equals 0.477, your y-intercept, plus your slope times log of x. You have to put that log in front of it. Okay, and that once again tells you that it's a power equation. All right, so now let's take a look at a question. Now that we have our equation, and it's important to make sure you have those logs in order to get correct answers for your predictions. How much would an Atlantic Ocean rockfish weigh at 18 years? So notice here we have our X is our age in years, so we're going to plug in 18 for X. All right, so we have our original equation, we took X, plugged in 18, literally type this side into your calculator. Once you do that, you get this. Now, you have two choices here. You can raise both sides to the 10 and know that 10, and since this is log base of 10, they cancel out and you're just left with y hat. And then this you would just plug into your graphing calculator, okay, exactly how you see it. Or if you are prefer to write it as an exponent, we know that there's an understood base of 10 equals 2.987. You can rewrite it as an exponent by saying 10 to the 2.987 equals y hat. Both give you the exact same answer, okay? All right, and then if you take a look at your table, if we put 18 in here and we say it's 970, we did not extrapolate here or go beyond our data. It kind of makes sense. It's between 768 and 1200. Okay, now if you wanted to, once again, you could reverse this equation and make it the power equation. You don't have to know how to do this. Honestly, you can do this directly on your graphing calculator. Okay, you can use, and when you do this on your graphing calculator, since you're finding the power regression, you would use list 1 and list 2 because that was original data formed a curve. Okay, that was a curve. But all we did right here is, number 1, we know that this this coefficient pops up as an exponent. Okay, that's my first step. Then what I can do is I can say, if we move the log over to the other side, okay, basically what I am saying is I have the log of y hat minus the log of x squared equals 0.4771. Okay, when you have a subtraction, remember whatever's here, okay, goes in your denominator. Okay, so log of y hat over x squared equals 0.4471. Okay, so now what we basically did here to get from this step to this step was rewrite this as an exponent. So this was base 10. So basically what I did was I said 10 to the 4.771 equals y hat over x squared. And then to get rid of x squared, I'm going to multiply both sides. Okay. But once again, you can get that directly from your graphing calculator. You don't have to know how to show all of your work for that. Okay. All right, so how do we get that from our graphing calculator? Great question, because you want to do it from your graphing calculator. You don't want to do it by hand, okay? So what you're going to do is you're going to go to Stat. You're going to go to Calculate. Okay, now notice down here, scroll all the way down, you should have something called Power Regression. Now, we knew to use Power Regression because when we transformed it, we knew it was powerful. We took the log of x and we took the log of y. So it was a powerful equation, okay? We knew to use power regression. So you're going to do power regression. Now remember, this is going to be list 1 and list 2. It's your original data because the original data was curved, okay? And then once you do that with your power regression, it's going to give you your answer. So y equals 3x squared. And notice it will tell you what this is and what your exponent should be. Okay, so let's take a minute and we're going to try this question. Okay, so what I'd like you to do is take a minute and try this one. I want you to decide which one is going to be your best fit equation. So number 1, you're going to put this in list 1 and this in list 2. Okay, what I'd like you to do is then on your graphing calculator, make a sketch of the scatter plot. Okay, after you make a sketch of the scatter plot, then make a sketch of the scatter plot of list. You're going to want to do 3 equations. So you have x comma y, then you have x log of y, and then remember you have log of x log of y. So remember this is list 1, this is list 2. This is list 1, this is list 4. This is list 3, this is list 4, okay? So make a sketch of those 3 scatter plots, okay? Determine which one looks the most linear. Make sure you compare the r and r squared values for both, okay? And then at the end, I'm going to show you how remember to show you how the residual plot also ensures that you have the line of best fit. Okay, so number 1, the first thing we did is we took a look at list 1 and list 2. Now notice if we graph it, that's pretty, that's pretty curved. Okay, so we can say that that is not a linear equation. So number 2, we take a look at the r and r squared. Not super high, 0.85, 0.96, but look at the residual plot. Okay, so the residual plot shows a clear pattern. Since that shows a clear pattern, we're going to say that this is clearly not linear and we need to find the linear equation. All right, so what I'd like you to do is try this, and then the next video we'll go over what the answer to this looks like.